Hi everybody. In today's video, we are going to continue solving another problem from LeetCode's top interview 150 problem list. So far, we have actually finished solving problems up to best time to buy and sell stock. If you haven't checked them out and would like to, please check my channel. So today, let's pick the one after that. Looks like it's a different version of best time to buy and sell stock. Okay, so let's read the problem and make sure we understand what the problem is. So you are given an integer array prices where prices of I is the price of a given stock on the ith day. On each day, you may decide to buy and or all sell the stock. You can only hold at most one share of the stock at any time. However, you can buy it, then immediately sell it on the same day. Find and return the maximum profit you can achieve. Okay, I see. So if you haven't watched the previous video where we solved best time to buy and sell stock, please go ahead and do that at some point. But to quickly revise, the difference between this problem and the previous version of the problem is, even in that problem, we were given an prices array, which indicated prices of a specific stock on various days. But in that problem, we were only allowed to make one transaction at most, which means you can buy once and sell only once. While here looks like we can do multiple transactions as long as they do not overlap, which means if you buy on day 1 and sell on day 3, then you can again buy on day 3 or even on day 4 and sell later. But if you buy on day 1 and sell on day 3, you cannot buy on day 2 because you are holding already the stock that you bought on day 1 on day 2. So anyway, the difference is that again, summarizing what I said, you can make multiple transactions of buy sell as long as they do not overlap with each other. Let's look at the examples that they have given. So prices input array is 715364. And here they are saying the best answer is 7, or the maximum profit is 7. And that's because we can buy on day 2 at price 1 and sell on day 3 at price 5, which is a profit of 4. And then we can buy on day 4 at price 3 and we can sell on day 5 on price 6. That is another profit of 3. So 4 plus 3 is 7. Makes sense. Basically, if we only did one transaction like in the last problem of 1 to 6, we would only make a total profit of 5, 6 minus 1. But since now we are allowed more than one transaction, we can actually buy at 1, sell at 5, buy at 3, and sell at 6. And that makes sense. In the second example, the prices is just 1, 2, 3, 4, 5. And the output is 4. And that makes sense. You can actually buy at 1 and sell at 5, as they are saying. But one more thing I noticed is that you could actually even get 4 by doing buy at 1, sell at 2, buy at 2, sell at 3, buy at 3, sell at 4, and so on, because that is allowed. Of course, you made that same amount of profit by doing more transactions than the previous one, but they don't ask us for the minimum number of transactions. They are asking us for just the maximum profit we can make. And the third example is 76431. Like in the last problem, this is an example where profit is 0 because the prices just keep on reducing. The constraints here looks like they're different than the previous one, but anyway, the length of the array is 3 times 10 raised to 4, so 30,000 less or equal to, and then between 1 and 30,000, and the prices of the stock are between 0 and 10,000, like in the last version of the problem. Okay, now this makes sense. Let's figure out an approach before we can code it up of what will work. So the approach that I'm thinking about, and to revise the approach we took 2 approaches in solving the previous version, but the more efficient approach that we took in the last version of the problem was that we basically to keep track of a buy price. So let's say buy price is 7 on the first day, potential buy price, and if we see the price on the next day or later, which is actually lower price, then we update our buy price. We say, okay, instead of buying at 7, I would buy at 1. Of course, you wouldn't make a loss. And then if you see a number which is bigger than the buy price, then you would say that is a potential profit I can make. For example, between 1 and 5 on day 2 and day 3, that's a potential profit you can make. And then you will say, you will keep track of the maximum profit. So again, if you haven't seen my previous video, I go into much more depth in that video of why that approach works, and it's an efficient way of doing it. Now, when I was reading this problem, I think a modification of that approach would actually work in even when we are allowed multiple transactions. And so let's go through this similar approach again. So let's say we have a buy price. We buy on day 1 at 7, right? In this case, let's actually add a 10 in the middle, okay? So now every time we see a number bigger, we can actually make that transaction completely. Like we don't even have to see further selling prices in the future to say, should I sell at 10? Because the reason is, if there was a 15 here or there was a 13, for example, as the third day price, then 7 to 10, the $3 profit can be booked, because then the next buy price would be 10, right? And so instead of saying 7 to 13 is 6, you say 7 to 10 is 3 and 10 to 13 is another 3. So you again get the same 6 total profit by doing 2 transactions. And so whenever we see a bigger number than the current buy price that we have remembered, we say, okay, I can just make that transaction and get the profit, because I can always buy again to book more profit if a bigger number comes. If we see a lower number, then we don't do that. We don't want to make a loss, right? And the buy price is always updated, because, like I said in this example, 7, 10, 13, since 10 is bigger than 7, we would actually book a profit of 10 minus 7. But then we could buy again at 10 in case a number bigger than 10 comes. So we remember 10 is the new buy price, right? So hopefully that made sense. Hopefully I didn't go over it too fast. Let's try to code that up. So is the int total profit. This time I'm going to call it total profit instead of max profit, because there are multiple transactions which can actually generate profit. And the first buy price, like last time, is prices of 0, and like last time, we are going to add a special if condition. If prices dot length equals 0, then return 0. And the reason is because we accessed index of 0 without checking whether we are within bounds or not. So this is kind of our check that prices of 0 is within bounds. Every time you do such a thing outside a loop or a condition which checks for whether your index is within bounds, you should add such error checks. Anyway, so, and now since we already did index 0 as the first buy price, we start from 1, and we say it's a day is less or equal to prices, sorry, less than prices dot length, not less or equal to, and plus day. Okay, and so now we are going through each day. And now again, the algorithm is that if the number is bigger, so let's actually just calculate profit, right? The profit is prices of day minus buy price, right? And if that profit is greater than 0, which will take care of negative as well, then we just add it to our total profit as if we did the transaction, right? And we just make now the current price as the buy price, always, without any condition, because we are allowed multiple transactions. So even if we book this profit by selling on this day, we can again buy on this day as well. So return total profit. Okay, let's run through the example we have here again manually before we actually run the code. So let's take 7, 10, 13, 1, 5, 3, 6, 4. Again, here the best answer is, I think, 7 to 10 is 3, 10 to 13 is 3. So 6 and another 4 here, 10, and another 3 from 3 to 6, that is 13. So let's see if we get 13. So okay, so we don't have this special case. Our total profit initially is 0, buy price is 7. We go to buy price, day equal to 1, index 1, and the profit is 10 minus 7. So profit is 3, and profit, since profit is greater than 0, we update our total profit to 0 plus 3, which is 3. We go to the next one, we look at 13, and 13 profit will now be, remember we updated buy price to 10 already, and then we go to the next one. So Profit is now 13 minus 10, which is 3. Again, profit is greater than 0. And so we add it to total profit. So we are at 6. And then the buy price now becomes 13. Go to the next one. We see a number which is less than 13, 1. So the profit variable will actually have minus 12 here, 1 minus 13. And so we will not add that to the profit because we are not going to do that transaction. But we do update our buy price to 1 in case we see a number bigger than that. Then we go to the next one, 5. 5 minus 1 will be 4. Total profit is now 6 plus 4, 10. And 5 is our new buy price, and so on. So I think this should actually work pretty well. Let's try to run this. Okay, compiler is easy to solve. Oh, yeah, I again have a typo in casing. Total profit. There you go. Okay, so in this case, it did get a 7. I'm going to add this case that I have here just because that is the one we took to understand our algorithm. Let's try this. Okay, case 4. Yeah, 13, like we said. Okay, there you go. Hopefully that made sense. One last note on this is time and memory complexity. Although it is very obvious, for the completeness sake, memory complexity is O of 1 because we are using constant number of extra variables and constant relative to the length of the prices array, which means no matter how small or big the prices array is, the amount of memory we need is the same. So that is what constant means. And obviously the time complexity is O of n because we are running a single loop in which there is constant number of operations and that loop runs for order of n times. So that there you go, our time complexity is order of n while our memory complexity is order of 1. Hopefully that was very clear. See you guys next time.